Every QA engineer running Selenium tests in a CI pipeline eventually runs into the same problem. The tests pass locally on your machine because you have a screen, a desktop, and a running browser. But on the CI server, GitHub Actions, Jenkins, or any Linux container, there is no screen. The tests crash immediately. Or worse, they run but behave differently than they do locally, and you waste hours trying to figure out why. Headless browser testing is the solution. Running a browser in headless mode means it executes all the same code, renders pages, runs JavaScript, handles events, but with no visible window. It is the exact same browser engine. The only difference is there is no graphical output. This makes headless testing essential for CI pipelines. It is also faster, because the browser is not wasting resources rendering pixels to a screen that nobody is watching. On a typical test suite, switching to headless can reduce runtime by 20 to 30%. In this episode, you will learn how to configure headless Chrome and Firefox in Selenium, how to handle the differences between headless and headed behavior, how to debug tests that only fail in headless mode, and how to make your fixture automatically switch between headed and headless based on an environment flag. This is a skill every professional automation engineer needs. If you cannot run your tests in a CI pipeline, you do not have a professional test suite, you have a local tool. Headless mode is what closes that gap. Let us start with Chrome because it is the most common. To run Chrome in headless mode, you use the ChromeOptions class to pass configuration flags to the browser before launching it. Create a ChromeOptions instance, then call options.add_argument of headless equals new. The equals new part specifies the newer headless implementation introduced in Chrome 1.12, which is more compatible with modern web apps than the old headless flag. You should also add no sandbox and disable dev_shm usage when running in Linux containers like Docker or GitHub Actions. These flags prevent common crashes in restricted environments. Pass the options to your WebDriver.chrome call. WebDriver.chrome of service equals your service, options equals options. That is all it takes. Your test runs with zero changes. The browser behaves identically, same JavaScript engine, same cookie handling, same network requests, just no window. For Firefox, the approach is similar. Create a Firefox options instance, call options.add_argument of headless, and pass it to WebDriver.Firefox. One important note, headless mode ignores the window size by default, which can affect tests that depend on viewport dimensions. Always set an explicit window size with driver.set_window_size of 1920,1080 immediately after launching the driver. The cleanest way to support both headed and headless modes is through your Pytest fixture in contest.py. Add a command line option that lets you toggle headless at runtime. Use parser.addOption in a Pytest_addOption hook to add a double-headed flag. In your driver fixture, read the value with request.config.getOption of headed. If the flag is present, run headed. If not, default to headless. This means your default behavior, the one that runs in CI, is always headless. When you are debugging locally and need to see the browser, you pass double-headed to the Pytest command and the fixture automatically switches. This pattern is used in almost every professional automation framework. It keeps your CI pipeline fast and invisible while giving developers the option to watch the browser when they need to debug. You can extend this further with a double-browser flag that accepts Chrome or Firefox, then your fixture dynamically creates the right driver type based on that argument. Combined with parameterize, this is how cross-browser testing in CI works. You run the full suite twice, once with Chrome and once with Firefox, and your fixture handles the rest. This entire configuration lives in one file, contest.py, which means your test files stay completely clean and framework agnostic. Here is a real example of configuring the full headless fixture in contest.py. First, define the Pytest_addOption hook and add your headed in browser options. Then define the driver fixture. Inside, read the headed in browser options. Create the appropriate options object, ChromeOptions or Firefox options, based on the browser argument. If not headed, add the headless flag. Always add the window size argument. Then create the driver using WebDriver.Chrome or WebDriver.Firefox based on the browser option. Yield the driver for the test to use. In the teardown after yield, call driver.quit. This single fixture supports 4 configurations: headed Chrome, headless Firefox, all controlled from the command line with no changes to your test files. Running Pytest double-browser equals Firefox double-headed gives you a visible Firefox window. Running Pytest in CI with no flags gives you headless Chrome. Every test automatically gets whichever driver configuration you specified. This is the architecture that scales from a 10-test project to a 1,000-test enterprise suite. The test functions never need to know anything about how the browser was configured. If you later want to add Edge or Safari support, you add one elif branch to the fixture, nothing else in your test suite changes. Debugging tests that fail only in headless mode is a specific skill. The most common issues are viewport-related failures, timing differences, and font rendering. Viewport failures happen when elements are off-screen or hidden in headless mode because the default window size is 0 by 0. Fix this by always setting an explicit window size as mentioned earlier. Timing differences occur because headless mode is faster, which sometimes means pages have not finished their JavaScript execution when Selenium tries to interact. Fix this by using explicit waits, not sleep statements. Font rendering differences can cause visual tests to fail. For screenshot-based assertions, capture baseline screenshots in headless mode specifically. When a test fails in headless but passes headed, the first debugging step is to take a screenshot at the point of failure. Add driver.save_screenshot of failure.png in your test or in a Pytest hook that fires on failure. The screenshot tells you immediately whether the page loaded correctly, whether the element is visible, or whether you are getting an error message that headless is suppressing. A common pattern is to add a contest hook using Pytest.hookempl that automatically saves a screenshot whenever a test fails, timestamped and named after the test. This turns headless debugging from guesswork into a systematic process. Recap. Headless browser testing removes the visible window while keeping full browser functionality. It is required for CI pipelines and faster than headed mode. Chrome uses headless equals new plus no sandbox and disabled devshn usage for container environments. Firefox uses headless. Always set an explicit window size after launching headless. Control headed versus headless through a Pytest command line flag so CI defaults to headless and local debugging can go headed on demand. When headless tests fail, use automatic screenshots on failure to debug without a visible window. These techniques are what make your test suite production ready, not just something that works on your laptop, but something that runs reliably on every pull request, in every environment, on every branch. In the next episode, we are turning raw Pytest output into professional test reports. You will learn HTML reports with Pytest HTML and full dashboard reports with Allure, the tool used by enterprise QA teams to communicate test results to stakeholders. That is episode 18. Subscribe to QA Career Lab and I will see you tomorrow. Headless testing is one of those topics that comes up in almost every automation interview. Being able to explain it clearly, including the CI flags and the debugging approach, puts you ahead of most candidates.